The number line is, as its name suggests, a line with a lot of numbers on it. Actually, it has every number on it. It's usually drawn as a horizontal line, and you can move along it in two directions. To the right, known as the positive direction, where the numbers get bigger, and to the left, known as the negative direction, where the numbers get smaller. You'll often see tick marks drawn on the number line, which usually indicate where the whole numbers are located. Let's draw a point at this tick mark, and suppose this point represents the number 2. If we move to the right, or in the positive direction, the numbers get bigger. So this point over here is 3, this point is 4, and this point is 5. So which number do you think is represented by this point over here? Right, this point represents the number 6. As we move in the negative direction, the numbers get smaller. So the tick mark directly left of 2 is 1. Which number do you think is represented by this point? Exactly, this is 0. And if we keep going left, we'll have negative numbers, like -1 and -2. Which number is represented by this point over here, 2 tick marks to the left of -2? Nicely done. This is -4. Let's assign the appropriate numbers to the remaining tick marks here. Now all these numbers we've written so far are called integers. An integer is any number that's a positive whole number, 0, or a negative whole number. Between the integers on this number line, we have all the numbers that are not whole numbers. For example, where on this number line would you say 3.5 is located? Precisely, the number 3.5 is halfway between 3 and 4, and so sure enough, it appears halfway between 3 and 4 on the number line. As a final challenge, take a look at this point over here. What number would you say this point represents? Close, but not quite. -1.5 is over here, halfway between -1 and -2. This dot seems to be closer to -1 than it is to -2. So give this question another shot. Excellent work! It turns out that this point represents -1.25. So the number line is a graphical, or visual, way to represent all the numbers, and we'll be using number lines, also known as axes, all throughout algebra.
To get started, let's draw in a number line, and let's mark off the integers from -3 up through +9. Take a look at this point over here. What number would you say this point represents? If you're not sure, click down here to review.
Right, this is halfway between 4 and 5, and it's about 4.5. Now let's move on to addition. Suppose you have the number 2, which is represented by this point over here, and let's say you want to add 3. This is a plus sign, which is the symbol for adding numbers. When you add a positive number, like 3, that means you're moving right on the number line. So 2 plus 3 means we can start at 2 and then move 1, 2, 3 to the right. And now we're at 5. So 2 plus 3 equals 5. Try using the number line to solve another example. What's 1 plus 7? And by the way, sum, S-U-M, is a word for what you get when you add numbers together.
Nicely done. This equals 8, and you can find that by starting at 1 and then moving 7 to the right. Sure enough, you're at 8. Next, try a few more examples. What's 2 plus 5? And also see what happens when we switch the order of the numbers so we have 5 plus 2.
Nicely done. Starting at 2 and then moving 5 to the right leaves you at 7. And starting at 5 and then moving 2 to the right also leaves you at 7. So 2 plus 5 equals 5 plus 2. In general, when you're adding numbers together, you can add them in any order and you'll always get the same answer. So next, let's see what happens when you add 0. For example, if you start at 7 and then move 0 to the right, where do you wind up? Precisely, 7 plus 0 equals 7. Whenever you add 0 to a number, you'll always get that number back. Next, let's add decimals. What's 2.5 plus 3? What do you get if you start at 2.5 on the number line and then move 3 to the right?
Exactly. Starting at 2.5 and then moving 3 to the right puts you over here, halfway between 5 and 6. So 2.5 plus 3 equals 5.5. Some